if I did start this? Where would my life be?
Okay, let's get started. So today I'll go over related rates and linearization. Yeah. So let me just say, do you all remember if I'm ddx, if the x is this x, right? Then you would just say it's 2x. Agree? But if the variable is different, then you do the same, but you get a y prime, right? That's implicit differentiation. So when the variables like don't match. So basically, to summarize related rates, it's what's rate? It's respect to time, right? So basically, it's ddt every variable. So your variable will not be t; it'll be other stuff, and basically, you'll be implicit differentiating every single one of them. So every time you take derivative, you get like a prime. Like if there's three variables, like if there's like a and w, then you're gonna get an a prime and like w prime from here, right? So basically, like variables either constant or depend on t. Yeah. So let me just say, how do you solve it? Normally it's like this, right? Equation relating variables. That's step one. And then differentiate and solve. That's pretty much it. So basically write out your variables, figure out an equation that relates them, and then derive. Yeah. So I'll do like a lot of examples today. So let's just at a rate at a rate of 6 centimeters per second. At what rate is the area of the square increasing when area of square is 16 centimeters squared? Yeah. So obviously it's asking for something with the rate of area, right? So obviously you should use an equation with area. So what's the area of a square? If I give you the square has side like length s, what's the area? Yeah. Okay, so we got the equation, that's step one, and then I told you step two is differentiate, right? So normally when you like just think of this as y, right? What's y prime? It's just y prime, right? What's y squared? It's 2y prime, right? So here this is just a prime, right? Or some people prefer dA dt, right? But let's just write a prime and then 2s s prime. Yeah. They give you s prime, right? S is the side, and it says the side is increasing at 6 centimeters per second. So this is just 12s, right? 6 times 2 is 12. Now it says, well, what is s? Well, it's asking for the rate when the area is 16 centimeters squared. So if the area is 16, what is the side at that point? S is 4, right? So a prime is 48 centimeters per second. That's your answer. Everyone good with this? So easy example. Nothing too hard yet. Okay. So let's move on. So the length of a rectangle. Is increasing. So we'll do a lot of related rates. It's increasing at a rate of 8 centimeters per second, and its width is increasing at a rate of 3 centimeters per second. When length is 20 centimeters, width is 10 centimeters. How fast is area of rectangle increasing? Oh, by the way, before we continue, homework 7 is going to be more related rates, so it's pretty important you understand this. So, anyhow, so what formula should I have? It's asking for area, right? So how fast just means derivative of whatever you do, right? So what's area of a rectangle? If this is my length, this is my width. What's area of a rectangle? Good. I'm not sure when it comes out. Yeah, the professor does all the releasing homework stuff. So like even I can't see it. Like I basically see it when all of you see it. But the only reason I know what's on homework 7 is because other classes are faster than us apparently. So and then like they asked me in tutoring center how to do the questions. So that's how I know. Okay. So how do I take derivative? So this is just a prime, right? That's what we want, right? How do I take derivative of this? What rule do I use? Yeah, product rule. So L prime times W plus W prime times L. And you see we have all the info, right? What's L prime? L prime is 8 centimeters per second, right? So 8 times, and what's the width? Well, it says when the width is 10 centimeters, right? Plus, what's W prime? Well, it tells you W prime is 3 times length is 20, right? What is that? 80 plus 60, 140 centimeters squared per second. Oh, did I not write square on the last one? Sorry. It should be centimeters squared on the previous one. Okay. Everyone good so far? Should be pretty simple. Let's do one more easy one and then I'll go over like a hard, maybe like a homework problem. Yeah. Suppose oil spills from a ruptured tanker and spread in a circular pattern. If the radius of the oil spill increases at constant rate 2 meters per second, how fast is area of oil spill increasing when radius is 30 meters? So any ideas what equation we should use? So it wants area, right? So yeah, it tells you it's a circular pattern, right? So it's area of a circle. And then same thing. A prime is pi 2r r prime, right? It tells you what r is. It tells you r is 30. Pi times 2 times 30. And it tells you r prime, right? It's increasing at a rate of 2 meters per second, the radius. So 2. So it's going to be 120 pi meters squared per second. Is it by seconds? Yeah. Yeah, everyone good? So you see, like once you have the equation, it's simple. The hard part is maybe drawing the picture and getting the equation. That's the hard part. Once you have the equation, you just differentiate, and boom, most of the time you have your answer. So okay, everyone follow. Yeah. So gonna do okay. So an area, a trough. I think this is a homework question. I don't know. Is 10 feet long. I just chose it. I mean, the web assignment is based on the book, and like it's kind of hard for me to think of word problems by myself. So I just took it from the book. Have the what does I even say? Oh, base 10 feet long, and it ends. Oh, I can't read my own writing. And have base of an isosceles. Oh, this is have base of an isosceles triangle. Sorry, I couldn't read my own writing. Have the base of an isosceles triangle that are 3 feet across the top and height of 1 feet. Yeah. So trough is being filled with water. Is being filled with water at rate 12 feet cube per minute. How fast is water level rising when water is 6-inch deep? Okay, so let's draw the picture. Yeah. So our trough is, I'm bad at 3D, but this is supposed to be 3D. Yeah. Like water is being filled like this. Yeah. So does everyone agree that, so if you look at it from just look at it straight this way, the water, if we assume it's straight, it's gonna form like, here's like the water, and then so it's gonna form a smaller triangle inside the bigger triangle. Yeah. Does everyone see that? So like, this is all water. Everyone good with my picture? I'm bad at drawing. So okay. So knowing that, right? So let's look here. So knowing that, let's call this is the height h, the height of the water. Yeah. And b, the length of the base. Yeah. So h equals height of water, and b is length of base. Okay, before I continue, what do I want? I want how fast is water level? Well, that's asking for the volume, right? And given anything, volume is always, if you forget, it's like the area for something like this. It's like area of base times area of base times the height. I guess height's the wrong word. So I guess like length, width. So I guess length in this case. So it's like area of this thing times how long this thing is, right? But we know it's 10 feet long. Yeah. Base. This is 10, right? It right here tells you it's 10. Area of base times 10. So you see, we almost have our equation. We just need to find what the area of like the triangle is, right? But it's not the area of the whole triangle. We know the area of the whole triangle, right? So here it's, let me draw it bigger. This is 3. They tell us it's 3. And they tell us the whole thing is 1, right? This whole thing's 1. But like we care about just the height of the small triangle, right? So here's B, and then this thing is H. Yeah. Any suggestions on how to do this? So this is geometry, right? So obviously V is 1/2 base times height, right? Times 10. Everyone good so far? Oh, shoot, wait, hold on. Sorry, it's asking for, sorry. How fast is water, it's asking for H prime. Sorry, my mistake. It tells you the, feet cubed, right? It tells you the volume at which the water is running. So it's asking for, I guess water level is like the height. So how fast is the height increasing? Okay, so I want H prime, right? I have V prime. So you see the issue is B prime. Yeah. The problem doesn't tell us what B prime is. Does everyone agree so far? So I need to find H prime. I have V prime, right? This is V prime. But like they don't tell me B prime. So I need to somehow change the B to like an H. That's like your first intuition. And from here you see it's similar triangles, right? So the base I mean this triangle, right? And this triangle, the big one. Yeah. So the bases should match. So if I compare base to height, this should be base to height. Yeah. And you see from here, 3H is B. Yeah. So this is, what is that? 3 over 2H squared times 10. I didn't make an algebra error. So this is 15H squared. Yeah. Now you're done, right? V prime is 15 times 2H prime. Okay, I want H prime. They tell me when H is what? When H is 6. Agree? 6 inch. So how much feet is 6 inch? How many feet is 6 inch? Because remember our thing is in feet. So 1/2, right? So this is V prime is 15 times, just making sure, I hope the rest are in feet. Okay. Well, from what I wrote, the rest. I don't know why they made like the last thing inch instead of just saying like 1/2 feet. But 2 times 1/2 times H prime. And we know what V prime is, right? V prime is 12. So what is that? 15H prime. What's 12 over 15? 3. 4 over 5? Yeah. Everyone clear on this? So it's just an extra step, right? You get your equation, you realize you don't have B prime, so you need to do more work. But really, it's still the same, right? Get the equation, differentiate, and you're pretty much done. Everyone good on this question? Yes. Okay. Don't worry. Once you do more and more of this, it should be pretty simple. So, see a spotlight on the ground. I think this is another homework question. I don't know. Shines on a wall 12 meter away. If a man 2 meters tall walks from the, I don't like this question because there's shadow, but let's just do it. Forward, forward, walks from the spotlight forward to the building at speed, speed 1.6 meters per second. How fast is the length of his shadow on the building? Decreasing. When he is 4 meters from the building. Okay, at least this question is nice, in the sense that it tells you where the shadow is. Like, there are other like shadow related rate questions where like it says a light is on him, and like unless you know like physics and stuff, even like I'm like, okay, does the shadow go like, is it north or is it south? Like I sometimes I don't even know which way the shadow, someone's shadow goes. But in this case, it tells you the shadow is on the building, so it's nice. Okay, so here's a spotlight. I can't draw a spotlight. Yeah. It's on the ground. It shines on the wall, so wall. So the wall's like the building, yeah. So shines on the wall, 12 meter away. So 12 meters. The whole this is the whole thing. Yeah, the whole thing's 12 meters. You have a guy, he's he's 2 meters tall, and he's walking towards the spotlight, right? At a speed of, so we can make like a triangle here. So let's let y equal height of his shadow. Yeah. So he makes like a shadow of himself. Yeah. This is y. Sorry. Let me draw this better. So let's make the wall bigger. Yeah, and then let's say the shadow is like right here. That's the height of the shadow. So let's draw it to here. And he just lost his head. Okay, so height of shadow on wall. Yeah. And let x be distance he walks. Yeah. So he starts at the spotlight, right? So the distance he walks is right here. Everyone agree? So you see the length here is 12 minus x. Everyone follow so far? My drawing is clear. So, okay. So it's asking for what? It's asking for dy dt, right? It's asking for y prime. So I need an equation relating, and what do I know? I know x prime. Yeah. It tells me x prime, right? Because if x is the distance he walks, then the speed at which he walks is x prime. So I need an equation relating y and x, right? And just like the previous question, this is similar triangles, right? I'm using this triangle, right? This triangle right here, and the big triangle right here. Yeah. So what's the base? What's the, let's go base, let's go height and base, right? So the small one is 2 over x, right? That's the height of the small triangle over the base. And then the height of the big one is y. And the base is 12, right? Everyone agree? So let's cross multiply. Y-axis 24. So I want y prime, right? So y equals 24 over x. If you like, it's 24x inverse. Okay, so let's find y prime. So y prime is, what is it? You can use quotient rule, you can use power rule. Either way, negative 24x to negative 2 dx dt. Or if you like, x prime. Okay, what is x? So it tells you, it wants y prime when what? When he's 4 meters from the building, right? If he's 4 meters from the building, this is the building, by the way, the wall, building, whatever you want to call it. If he's 4 meters from it, how much has he walked? The whole thing's 12 meters, right? So if he's 4 meters from the building, what is x? 8, yeah? So this is the distance from him and the building, right? So if 12 minus x is 4, x is 8, right? So y prime is negative 24 over 8 squared, 64, right? Times x prime. Now, yeah, so x, what is x prime? X prime is 1.6. So it's whatever this number is, yeah. Negative 24 over 64 times 1.6. What is it? Meters per second. Okay. Everyone follow? You see, I'm not doing anything different. I'm saying the hard part is right here. The hard part is just getting the picture. Once you have the picture, and you get the equation, you're pretty much done most of the time. Everyone follow? Good. Okay. So let's do more. 2 cars start moving from the same point. One travels south at 60 miles per hour, and other travels west at 25 miles per hour. At what rate? By the way, I won't really have time to cover differentials, though I think that's just definition. Just look at the book. They pretty much define what it is. So, because I figure related rates and linearization is going to be the hard part on the homework. So I'm just going to spend time on that. What rate is, I don't think differential is that bad, is the distance between the cars increasing 2 hours later. I guess I would have time if we had discussion Thursday, but we don't. Okay, so let's say this is the point they start, right? So car 1, right? Where does it go? It goes south. it goes south at 60 miles per hour, right? And then the other one heads west at 25 miles per hour, right? So let's let x equal distance car one. So the car one is, the south one. Yeah. Car one travels after, after like, I don't know, t hours. Yeah. And then y be distance car two travels after t hours. Right? T is, just a variable. So this is x, this is y. So what's the distance between them, right? It's asking for the distance between the two cars. What's the distance? So if the car is like here and the car is here, the distance is here, right? So it's asking for d prime. So question, I know x prime, I know y prime. It's literally just this, right? So what equation relates d, y, and x? Believe me, it's something you know. Yeah, exactly. See, you all got it. Oh, no. Okay, sorry. I can't believe I did that. But let me just say, yeah, it's Pythagorean theorem, right? Sorry, I can't recover that, but since car one travels, I don't know why that happened. Y equals distance car two travels. So hopefully you all remember the question. Yeah, travels after time t. Yeah. So again, this thing is 60 miles per hour, 25 miles per hour, and it's asking for a rate of distance between cars 2 hours later. So yeah, it's Pythagorean theorem, right? It's d squared is x squared plus y squared. So this is 2d d prime, yeah, equals 2x x prime plus 2y y prime. Now, what's the distance between them 2 hours later, right? So let's say 2 hours later. 2 hours later. If the car travels 60 miles an hour, 2 hours later it traveled 120 miles, right? And 2 hours later, since this one goes 25 miles an hour, this one's 50, right? And if you use Pythagorean theorem, you're going to figure out d is 130. Yeah. So that's it. So 2 times, what's x? X is 120, right? Right here. And x prime is, what's the rate? Well, it's 60 miles an hour, right? Plus 2, what's y? It's 50, right? And then what's the rate? It's 25. If you solve for d prime, then you just do the algebra, you're going to get 65 miles an hour. So I got these numbers because I'm using this, right? It's asking for what's the rate when it's 2 hours later. Everyone good so far? Yeah. Sorry, the screen went out. Okay. Let's do one more. Boat. I think this is also homework. I don't know. I think I picked a lot of homework questions. Pulled into a dock by a rope attached to the bow of the boat and passing through a pulley on the dock that is one meter higher than the bow of the boat. If the rope is pulled in at a rate 1 meter per second, how fast in meters per second? In meters per second is the boat approaching the dock when it is 9 meters from the dock? Yeah, this thing's long. Okay, so let's write it, right? Here's my boat. I'm not gonna, I don't know how you draw this. Here's the boat. Yeah, and then so this boat. It's here's a pulley. I don't know how to draw a pulley. I'm just gonna write pulley. Yeah, I know. And then this is the rope, yeah. And then the pulley is dragging the boat in. So when the pulley drags the boat, right, the rope becomes shorter and shorter, right? So, and then this is the length X, and here's the dock, yeah. And this is the pulley, yeah. So, let's let Y be length of rope connecting boat to pulley. So it's, just the rope. And, let X be the distance of boat from dock, right? Boat from dock. Yes, I guess the question doesn't really make sense in real life. But okay, so and it tells you this is 1, right? Because the pulley is 1 meter above the boat. Yeah. I guess bow of the boat is the floor. So so okay, so what do I know? What do I want to find here? How fast is the boat of the dock? A boat approaching the dock, right? So if X is the distance from the dock, you see it's we want X prime, right? We want X prime, right? And what do we know? We know. Let me see. Do we know Y prime? Yeah, right here. So if Y is the length of the rope, then the rate at which the rope is pulled is Y prime, right? So we know Y prime. So we need a formula relating X and Y. So what formula is it? I don't know why. I mean, there's no angle. It's not asking for any angle. I mean, look, you have this, and this. What formula relates them? If I mean, forget the picture. I say this is X, this is Y, this is 1. What formula relates X and Y? Yeah, it's Pythagorean again. Yeah, so I know that y squared is x squared plus 1. So let's just derive it, right? So 2y prime is 2x x prime. Okay, we want x prime, right? So divide by 2x. X prime is y over x. The 2's cancel times y prime, right? So what's y prime? If it's being pulled in, is the length of the rope increasing or decreasing?
Decreasing.
So is it what should I put for y prime? Yeah, it should be -1. Yeah. So this is. I mean, just think about it. Like if you're decreasing, your slope's negative, right? If you're increasing, your slope's positive. So what's y over x? Well, it says when I am 9 meters from the dock, right? So this is when x is 9. But when x is 9, I could find what y is, right? I mean, using the Pythagorean theorem, right? 9 squared plus 1 squared is y squared. So y squared is 82. Y is square root of 82. Yeah. It should be plus minus, but if y is length, you can't have it clearly cannot be negative square root of 82. You can't have negative length. So it's square root of 82. So square root of 82 over 9 times -1. So that's your answer. Meter per second. And it should be negative, right? Because the distance from the boat to the dock is decreasing, right? Everyone clear? I hope you can do the rest of your homework. So I didn't look at the rest, but you know, the what do you call it? The trapezoid one is kind of like the other trough one I did, except instead of the isosceles triangle, right? Remember? I remember the not beautiful picture I drew. Except in this case, it's a trapezoid. Something similar, yeah. So your formula would be like area of the base, which is area of the trapezoid, times the length. And I think it tells you the trough is like something meters long. So like you have the length. So you just need to find what area of the trapezoid is. Okay, everyone good. So I'll let you do that for practice. Okay, let me do one more thing. So approximation, right? So if I have a function, this is the classic example I do. If this is the tangent line to like, A. So you see that for points close to A, right? The value of the line, I guess I didn't draw this well, but the value of the line is pretty close to the value of the function. Yeah. So if I draw it better, so you might sort of see it. Yeah, like right here, like right there, the values are like really close, right? So that's pretty much what linear approximation is. So to approximate something you don't know, you go with something you do know. So for example, if I asked you to approximate square root of 4.02, yeah? I don't know what square root of 4.02 is, but is there something close by that I do know? Yeah, square root of 4, right? Yeah. So you see here, right? Let's take our function to be root x, and let's take tangent line at 4, right? at like a equals 4. So the tangent line at 4, right? Similar, I mean, this is not root x, but if you think of this number as 4, well, 4.02 is pretty close, right? So the value is going to be pretty similar, right? What's the tangent line? It has 0.42, right? And what's the slope of the tangent line? The slope is f prime of 4, which is, well, what is f prime of x? F prime of x is 1 over 2 root x, right? So 1 over 2 root 4. So that's 1/4, right? So your tangent line is y equals 2 plus. Everyone good so far? This is equation. I did a bit fast, but equation of tangent line. Everyone good with that? Or did I need to slow down? Okay. And then you just plug it in. Plug in 4.02. That's the last thing you do. And whatever answer you get is, this is approximately, is not equal, right? We're approximating, right? Is approximately square root of 4.02. Yeah, so I think on your homework, it asked for like square root of like what? 0.98? So, I mean, what was it? I guess, can someone tell me what the number you have on your homework is? Does anyone on WebAssign, what number do you get? I mean, I chose 4.02. It shouldn't be. Yeah, if it's like 0.98, so what number do you know what square root of a number do you know that's close to 0.98? That, what number is, yeah, exactly. So you do the same exact thing, right? Okay, that's all I have. So again, just I don't think the differential thing is too hard. Just look at the book. It pretty much defines what it is. It's just derivative dx. So hopefully you could do all the related rate questions, because I feel that's the hard part. Yeah. Okay. I'll see you next week, Tuesday. Yeah, we don't have class on Thursday.